Hello, let's look at Fibonacci series and Lucas series. Fibonacci sequence is a sequence of numbers where each pair of two numbers is added up together to get the next number. So 0 plus 1 gives you 1, 1 plus 1 gives you 2, 1 plus 2 gives you 3, 2 plus 3 gives you 5, 3 plus 5 gives you 8, and so forth. It's called the Fibonacci sequence. Now let's look at what is the Lucas sequence. Lucas sequence is similar except that it starts with 2 and 1. So 2 plus 1 is 3, 1 plus 3 is 4, 4 plus 7 is 11, and so forth. So an interesting thing about Fibonacci sequence, if you took each number in the Fibonacci sequence and divided it the next number with the current number, and you do that in a sequence, you will see that there is something very interesting about this series. So if I take the transpose of it, I can see if I divide, for example, 3 by 2, which will be 1.5, then 8 by 5, and so forth. So 8 by 5 is this 1.6667. And if you keep on doing that, you tend to go to a particular number that is very, very interesting. It's 1.6803, and so forth. And this so happens is the golden ratio. So golden ratio is basically 1.6180339887498895. So you can see that it is tending towards the golden ratio. So Fibonacci series, if you divide each number with the next, will reach the golden ratio. Now Lucas sequence, on the other hand, has something very interesting, that if you did the same thing with Lucas numbers instead of Fibonacci, different kind of sequence. So let's also transpose this one so we can see it clearly. Just do the transpose. So it goes like 0.53, 1.3, 1.75, 1.57, and so forth. It also tends to go to 1.618339. It's kind of like the golden ratio. Now there's something very interesting about the Lucas ratio. That is, if you took the golden ratio, you created the powers of golden ratio, like golden ratio to the power of 1, golden ratio to the power of 2, ratio to the power of 3, and so forth, and then you rounded those numbers. Then, so on the left you are seeing the power of golden ratio, that is golden ratio to the power of 1, golden ratio to the power of 2, golden ratio to the power of 3, and so forth. And you see, if you round it, you get the sequence 2, 3, 4, 7, 11, 18, 29, and so forth. And that happens to be the same as the Lucas sequence. So it goes like 3, 4, 7, 11, 18, 29, 47, 56, and so forth. So we say that the Lucas sequence is closer to the golden ratio property, to the powers of golden ratio. And Fibonacci series, if you take each pair and you divide the second one to the first, and you continue to do that, you will tend towards the golden ratio. The golden ratio is basically 1.6803, and it's actually the rational number. So to find the actual value of it, it's actually 1 plus square root of 5 divided by 2. So this will give you the value 1.68. And there are two pairs to this one. There is another one which is 1 minus square root of 5 by 2, because it's actually a solution of a quadratic equation. So if you take the equation for golden ratio, which is 1 plus square root of 5 by 2 and 1 minus square root of 5 by 2, and here we activate the D100 to calculate the decimal up to decimal place of 100 places, with ops.on, and if you do the computation, you will get the ratios as 1.6180339888, and so forth, and the other solution is minus 0.6180339887, and so forth. Now remember that each of them are, except for the one on the left, both the numbers are pretty much exactly the same. So it's, if you remove the one from here, it's 618033998, and so forth. And you can see the other side is also 6180339, and so forth. Now if I put D100 here for the second part, I will get that also to the accuracy of, the 100 decimal accuracy. Now, there's a lot more to talk about golden ratio, which we'll be doing in another video. So we'll look forward to seeing you there. But that's the relationship between Lucas numbers, Fibonacci numbers, golden ratio, and the different varieties of golden ratio.